Welcome to the StratusLab video. This video describes the StratusLab Infrastructure as a Service cloud distribution and its use. StratusLab is a collaboration of 6 partners from 5 countries. The project is co-funded by the European Commission. The purpose of the project is to bring cloud and virtualization technologies to existing grid and e-science computing infrastructures. We do this through our open source cloud distribution. Combining the benefits of cloud technologies with existing infrastructures makes those infrastructures more flexible and more capable. Why would a scientist or engineer like to use a cloud? One reason is the ability to have a customized computing environment. You can use operating systems suited to your application, use or create virtual machines with your applications pre-installed and configured, and finally, dimension those machines with the CPU, memory, and swap space for your applications. In bioinformatics, researchers have huge data sets that are growing in number and size, numerous applications that are written for different computing environments and that have different requirements. They also use a variety of databases that are continuously being updated. The challenge is to create the computing environment where all these can be used together for a complete scientific analysis. To do this, IBCP, part of CNRS, has created a couple of customized appliances. The BioCompute appliance contains a large number of common bioinformatics applications that are pre-configured and ready to use. The BioData appliance acts as a broker to common databases. It also ensures that the cached copies of the databases are current. IBCP has also created a prototype bioinformatics portal that simplifies access to and the use of cloud resources. Toscani is a project from the Pasteur Institute in Paris that looks to improve the determination of protein structures with nuclear magnetic resonance data. ARIA is the software used for this analysis. ARIA appliances have been created that allow an analysis platform to be created inside a StratusLab cloud. The platform then adapts and scales to the CPU needs of the current calculation. Another reason to use a cloud is for dynamic provisioning. This allows storage and compute resources to be allocated and used in minutes. Equally important, these resources can be freed just as quickly for reuse by someone else. This makes clouds ideally suited to variable workloads. This feature can be used to create dynamic training infrastructures. With the cloud, there is no need for dedicated training infrastructures. Instead, the infrastructures can be created on demand in the cloud. This also allows each student to have his or her own dedicated system. Narval is a data acquisition framework used by several nuclear physics institutes. Understanding the system requires installing, using, and customizing it. This is challenging with fixed infrastructures, but easily handled with the cloud. The Narval developers successfully trained 20 students using Narval infrastructures deployed within the StratusLab cloud. Similarly, one can imagine having a dynamic testing infrastructure in the cloud. Developers can easily test software in multiple environments. Moreover, they can deploy full systems independent of other developers and avoid interference between them. The Slipstream product from 6 Squared, one of the project partners, provides a software engineering platform as a service for automated deployment and testing of software systems. This project uses StratusLab for dynamic provisioning of resources for those tests. Another reason to use the cloud is for flexible service deployment. With the cloud, user-level, network-accessible services can be deployed and maintained. These can grow into full domain-specific analysis platforms. High-energy physics has experiments with thousands of users, petabytes of data, distributed between hundreds of sites around the world. These experiments develop and maintain their own software services and platforms. One of these systems is Dirac. It is a general master worker framework for analyzing high-energy physics data. We have been working with the developers to port this platform to the cloud. Dirac potentially benefits from this by simplifying the code controlling the interactions between the master and workers. In addition, they can also deploy the master and other central services in the cloud, rather than having to maintain a separate infrastructure. Potentially, they can use this for deploying redundant services for better reliability. Grid infrastructures are another platform that support high-energy physics data analysis. GRNet has deployed a production grid site within StratusLab Cloud and maintained that site for nearly 2 years. This demonstrates that the cloud, and in particular the StratusLab cloud distribution, can host complex services and run those services at a production level. Interest in the cloud is not only from academic institutes, there is also commercial interest in the StratusLab software. One example of potential commercial use is a proof of concept for an end-tier web application. With Cloudio, one of the StratusLab services, an administrator can deploy the entire web application and, more importantly, allow the various tiers within the application to auto-scale in response to demand. There are also two commercial products from 6 Squared using StratusLab. Slipstream, which you've already seen, provides a testing platform for software systems. DS Cloud ReadyPack is a turnkey cloud solution for SMEs. Both of these projects are powered by StratusLab. You've seen examples of people using StratusLab, but what services are provided? StratusLab provides infrastructure as a service cloud. First, there's a system for appliance management. The marketplace is at the heart of appliance handling mechanisms in StratusLab. The service helps establish trust between appliance creators, users, and administrators. You can browse the marketplace to find existing appliances that interest you or share your own images with others. To lower barriers, the project provides appliances for many common operating systems and for EMI grid services. Other projects, like IGE, also use the marketplace to publicize their appliances. The core services of StratusLab provide compute, network, and storage resources. The compute services are provided through OpenNebula. With this, you can create virtual machines with CPU, memory, and disk resources that you need. When deploying machines, you can request public, local, or private IP addresses. These allow you to run your own services, parallel applications, or workers in the cloud. For storage, you can use the StratusLab services to create disks for data storage. These disks can be persistent, volatile, or read-only. They can be allocated, attached, and detached dynamically from the command line client or via the web interface. You have already seen the service management feature of StratusLab. Cloudio allows the deployment, control, and auto-scaling of multi-machine services. Security is not neglected by the project. StratusLab has flexible authentication mechanisms that allow users to identify themselves through usernames or certificates. Cloud administrators can create policies to control what appliances can run on their infrastructures. The services provide detailed logging, and if the need should arise, a quarantine of stopped images allows for detailed forensic analysis. I hope that I've convinced you that using the cloud is interesting. To get started, just push the Get Started button on the StratusLab webpage. Or perhaps you're an administrator that wants to make your infrastructure more flexible by running a private or public cloud. Follow the install link on the StratusLab website. StratusLab is easily installed and supports Fedora, OpenSUSE, and CentOS. Thanks for taking the time to learn about the StratusLab cloud distribution. For more information, please visit the project website.